Right, I'm going to tell you about alternating current and direct current. So basically, the learning objectives are, you've got to know what AC current is, know what DC current is, know what AC and DC look like on an oscilloscope screen, and if you're higher tier, you've got to know how to obtain the peak voltage and frequency of alternating current on an oscilloscope. So basically, there's two types of current, AC and DC. Right, let us tell you about DC first, because that's the easiest. So DC stands for direct current. Now, you've got to know how the electrons flow, you've got to know where DC comes from, and you've got to know a little bit about the voltage. So basically, electrons flow in one direction. Right, well, if you're thinking, what does that mean? Right, I'll show you. Well, for starters, the second thing is that DC comes from a battery or a cell. So I've got the positive side of the battery here and the negative side of the battery there. Electrons are negative, so technically they come out of the negative side of the battery or cell. If you're talking about conventional current, mind you, that would come out of the positive terminal and go to the negative. But since we're talking about specific electron flow, the electrons come out of the negative terminal and go to the positive terminal, and they just keep going round in a steady loop. And because the flow is steady, that means that the voltage is steady. And that's it for now. I'll show you what it looks like on the oscilloscope screen when I get to it. Right, the other type of current is alternating current, AC. Now, when students get the name wrong, what they do is they call it alternate current. That's wrong. It's alternating. Now again, you've got to know how the electrons flow. Now this time, the electrons flow back and forth, and basically they change direction 50 times in 1 second. So what we say is they've got a frequency of 50 Hertz. Now again, you might be thinking, what does it mean the electrons are flowing backwards and forwards? Right, well, AC comes from the mains. And by that I just mean the main source of electricity in your house, which is the plug in the wall. Now, for 1 split second, the electrons will be flowing, as I've drawn here, in a clockwise direction. And then, a split second later, it'll be flowing in an anti-clockwise direction. And in England, the current is reversing 50 times each second. So for 1/50th of a second, the current's flowing clockwise, and then a 50th of a second later, it's flowing anti-clockwise, and then another 50th of a second later, it goes back to being clockwise, and it keeps doing that. Now, you're supposed to know where AC comes from. So AC comes from the mains. And then you ask yourself, well, where does the electricity from the mains come from? Right, it comes from power stations. It's generated in power stations. And that's why the current reverses, because a generator is what's used to generate the electricity. And a generator is basically a massive magnet inside a coil of wire. And as the magnet spins, it's like going north, south, and that makes the current go backwards and forwards, backwards and forwards. And so basically the magnet in the generator is spinning 50 times a second, which means that the current is reversing 50 times a second. You'll find out more about that in another lesson. Now, if you're higher tier, you're also going to have to know how big the voltage is. So basically the voltage alternates between plus 325 volts and minus 325 volts, and that'll be in the live wire. And that's actually equivalent to a direct voltage of 230 volts. That's what the mains supply is in England. It's 230 volts. Now, the examiners will often ask you about approximate voltages. Right, well, you've got a car battery which is 12 volts and it's a battery, so that'll be DC. You've got the mains voltage that I've already said is 230 volts, and that's AC. You've just got normal little cells, that'll be about 1.5 volts, and that'll be DC. And also, as I've said, the max voltage or potential of the live wire is plus 325 volts, and that'll be AC. Right, let us tell you about these cathode ray oscilloscopes, CROs, or we just call them oscilloscopes for short. This is basically what an oscilloscope looks like. An oscilloscope can basically turn electricity into pictures, it can turn sound into pictures, all sorts of things like that. You might have saw them in a hospital doing a heart monitor. Yeah, that's the same thing. Right, what we're interested in is look closely at the screen. It's got like a graph paper on the front. You've got your x-axis, which is coming across from left to right, horizontally, and you've got your y-axis, which goes up vertically. Now, you can use these little knobs and dials to change the size of the settings. So you might have it so that 1 square up means 1 volt going up, or you might have it so that 1 square up means 10 volts. You know, you just set it how you want it. And also, going across on the x-axis, we usually have the time, and again you can set it so 1 square across might mean 1 second, or it might mean 10 seconds, or it might be 1/10 of a second, or even 100th of a second. You just turn the knobs and set it how you want to set it so that your picture looks canny. Now what I'll do is I'll put some graph paper over the top of it, just like that, and actually I'll get rid of the oscilloscope now. It's served its purpose. Right, that's better. This is what you'll have in an exam. It'll show you what the voltage is up the side, and it'll show you what the time is along the bottom. Now, the good thing about the alternating current and the direct current is they look totally different on an oscilloscope screen, so you can't get them wrong. Right, so basically, if you get a pattern going up and down like this, you know that was produced by an alternating current, because the voltage is alternating. You might get asked, they'll say, oh, look at this picture here. Say, what's going on with that? Well, that's basically AC, but it's got a higher frequency. And that's because there's more waves per second. Remember, if the wavelength gets shorter, that means that the frequency is getting higher. Okay? One thing gets smaller, the other thing gets bigger. Now, if they do ask you to draw the same wave, but with a higher frequency, you've got to make sure that the height of the wave is the same as the original wave. I mean, they might turn around and say the voltage is less, in which case I'll show you how to draw that as well. Basically, the height will change if the voltage changes. So, look at this. There's your screen there. And they might say, oh, look at that wave there. And then they'll say, there's this wave here. They'll go, what's the difference? Well, you can see it's still the same frequency. That's one wave there, up and down and back up to the middle again. This one's from the middle, up and down and back to the middle again. So there's both one wave is being shown over the same amount of time. But this would be a low voltage because it hasn't went as high. And this one's a high voltage. So that's easy. That's as you'd expect, isn't it? Now, what about DC? So, DC, well, it's a direct current, isn't it? And a direct current produces, look at the state of that square. Direct current simply produces a direct line. So, just say that dotted line there is the zero line, right? Basically, you're going to end up with a line like that. And what would DC look like? A small amount of voltage then a high amount of voltage. Well, there's your low voltage. And there's your high voltage. Whoops. That should be a straight line. Better do that again. Still a bit wobbly. Right, do you see how the line's gone from there and it's gone up a little bit, right? It's a bit higher, isn't it? That's what I'm trying to show you. So there you go. Easy peasy. Right, so this bit's just for higher tier candidates. You need to know how to work out the following from a CRO screen. The peak voltage, the period, and the frequency. Right, I'll start with the peak voltage. So the peak voltage is basically the maximum voltage. Right, let us draw a nice graph. Right, this is basically a wave. Going up, going down, keep going down, back up to the middle. Now, that is one wave, okay? So the wave length would be from there to there. Now, the amount of time that it takes for that to happen is called the period. I'll tell you about that in a second. Now, the thing is though, the graph on the oscilloscope, it doesn't just show one wave. It shows multiple waves. So let us just keep drawing a few more waves. Give us a minute. Right, let us draw the rest of this wave. Right, so the peak voltage is basically just the highest voltage. So you can see the highest voltage is here. So that is basically your peak voltage there. And in this case it would be 325 volts. Now you're also supposed to be able to know the period. And the period is the time taken for one complete wave or one complete cycle. In this case, one complete wave has took 0.02 seconds. So there we go. So you can get the cycle either, you can see I've started from the middle here and then I'm going up. So I need to get back to the middle but going up, right? So hang on, that's back to the middle but it's going down. So that's not a full wave yet. So I'm back to the middle now and I'm going up. So basically that position there is exactly the same as that position there. If you get confused in an exam, you could just go from peak to peak. That's a full wave as well. Or you could go from trough to the next trough. So the wave is just basically any position to the identical position but on the next wave. Now, once you've got the period, you can work out the frequency and I'll show you how. So first of all, the frequency is how many waves there are per second. Now that's important, per second. Right, so basically there's an equation which says frequency equals 1 divided by the time period. And remember the time period is the time for one wave. Now if you're wanting your frequency to be in hertz, which we do, the time period has to be in seconds. If you're making your own notes, make sure you bang that in a box so it stands out on your page. Right, so let us give you an example of that then. So the frequency is 1 over the time period. And in that case, it'll be 1 over, look at this, the time period is 0.02. So from there to there, took 0.02 seconds. And if you do that over that, it comes out as 50 hertz. Hey! So I told you, the frequency of the mains in England's 50 hertz. Now in different countries it'll be different, but even if you're sitting your exam in England, they don't have to make the frequency 50 hertz. They could just say it's some random source of alternating current, not necessarily from the mains. And that's pretty much everything you need to know for that. So I hope that's been really helpful. Oh, and here's a quick question. If I'm going to do a few videos of this style, would you prefer that I draw on a white background or would you prefer that I draw on a black background? Just in case you're watching it on a night time in your bed. I don't want it blinding your eyeballs. Right, work hard, be nice. Ta-ra for now.